Hello friends. It's time for another lesson on the Home Assistant Smart Home Management System. This time, I've decided to focus on an integration that enables control and monitoring of EcoFlow charging stations. I own several stations from this manufacturer, and I chose them for several reasons. They can be used similarly to standard UPS systems, meaning you can just set it up and forget about it, although it has a slightly longer switch time to the battery at 30 milliseconds. They use lithium iron phosphate batteries with several thousand charge-discharge cycles, provide fast charging, and offer convenient management. Adding these to Home Assistant will allow you to use the devices and automations, receive status notifications, toggle output interfaces on and off, and more, including accessing parameters that aren't even available in the official app. For more details, stay tuned for my lesson. In the meantime, as usual, I'd appreciate it if you could like this video so that more people interested in smart home topics can find it, and subscribe to my channel if you haven't already. I won't be covering the installation, registration, and addition of the charging station in the official EcoFlow app in this lesson. Everything there is quite straightforward. However, this is a mandatory step for all further actions. It also makes sense to update the station's firmware versions and register them in the warranty program. The email and password you create during this process will be useful later, so make sure to save this information. The link to the EcoFlow integration repository is in the description below the video. At the time of testing, it hadn't yet been added to HACS, so you'll need to do this manually. Copy the link. Next, open the HACS page. If you haven't installed it yet, there's a link to the tutorial in the description as well. Here, you'll need to go to the menu by clicking the button in the top right corner. Then, select the Custom Repositories section, where you can add this and similar projects. Here, paste the copied GitHub project link and select its type, Integrations. If everything is done correctly, the integration will appear in the list. Besides this one, I've also added another project for managing switches with PoE. After adding it, the integration can be found in the HACS list just like any others in this repository. Then, install it. This process is no different from installing other integrations from HACS. To apply the changes, the system will ask you to restart Home Assistant. After the restart, the integration will be available in the Standard menu, where you can find and set it up. The integration will suggest creating a group for the devices, which is called Home by default. You can have one or multiple stations in a group, depending on what works best for you. Next, a window will open asking you to select the API usage. At the time of testing, there are two options, Public and Application API. According to the integration's author, it's recommended to use the Public API, as the Application API might be disabled, but I will review both options, starting with the Application API since it can be used immediately. To use the Application API, you'll need to enter the email and password you used to register in the app. Afterward, the window for adding the charging station will open. Device type. Here, you'll need to select your station's model, as the number and types of settings depend on it. Next, specify the device name. This will appear in the system, and the serial number, which can be found either on the sticker or in the app. That's it. The station is now added to the system. Here's how it looks in the Integrations menu. I've created one group with one station added to it. There are controls for the inverter output, 220V, the ability to turn the DC port on and off, control modes for continuous inverter operation, reservation settings, X-boost mode, battery charge level, time remaining until charging or discharging, and health status. You'll find all the settings related to output shutdown times, charging current, and connection types for the XT60 port, as well as allowed charging/discharging levels and screen/device shutdown times. In the diagnostic section, there are many parameters, voltage and power on input and output, battery and inverter temperature, charge-discharge cycle count, and more. This provides much more information than the standard app. If, like me, you have multiple stations, you can add them in two ways. You can either use the Add Entry button, where you'll be prompted to create another group and add another station, as I've already shown. Or you can use the Reconfiguration menu if you want to add the station to an existing group. Then, follow the same process, entering the email and password from the app. For obtaining the public API, The process is longer but ultimately more correct and convenient for future use. You'll need to visit the EcoFlow developer's website. The link is in the description. Use your app login credentials to access it. Here, go to the IoT background section. At this point, and in some other cases, the site will ask you to verify your account by sending a code to your email, which you'll need to enter within a minute. On your first visit to this section, the application process for developer status needed to obtain the API key will begin automatically. This process can take up to 5 days, so you'll need to check back periodically. Once approved, a button to generate the access key will appear in this section. The key consists of 2 parts, an access key and a secret key, both of which are needed. When selecting the public API option in the integration, you'll need to enter these keys in the corresponding fields in the next window. The integration will then automatically detect all charging stations linked to your account, and you won't need to manually enter anything. The device type and serial number will be filled in automatically, and you'll only need to specify the device name in the system. The controls and sensors will be the same as when using the application key, including battery health status and charge-discharge cycle count. To add a new station to the same group, select the Reconfigure option from the menu on the right. You won't need to enter the keys again, as they'll already appear in the window. Then, choose the Add Device option. The list of devices will appear again, and you can select the next station. If everything is done correctly, the reconfiguration will apply successfully, and the station will be added to the same group. If you need to create a new group, use the Add Entry button. In my case, I added 4 stations, 1 EcoFlow Delta 2 and 3 River Series stations. Here's how I set up the page for these stations in the interface. I displayed the key entities, controls for AC and DC outputs, readings for input and output voltage, sliders for setting the charging power, and the maximum and minimum charge/discharge levels for the battery. Then, there are indicators for the current battery level, health status, and cycle count. At the bottom, I placed the PowerFlow card plus cards. You can find the link to its repository in the video description. On the left are energy sources, inputs from the grid, car/solar charging, and the battery. On the right is the total consumption and the distribution across outputs, the inverter, USB-A, USB-C, and DC-12V. Let's run a test. I'll disconnect the grid input from the River 2 station. It's on the right. The input voltage is now 0. Here's how it displays on the diagram. The grid power is 0, and the battery is supplying 45 watts, which goes to total consumption and the inverter output. The difference between the total readings and the inverter output, I attribute to some data delays from the cloud integration. I also had to create custom power sensors for the battery, both charging and discharging. I'll show you how I did this a little later. Now, I connect the car/solar input, which I use for this purpose. I'll show what I use a bit later. The power distribution now looks like this. 44 watts go to consumption, and 10 watts go to the battery. I reconnect the grid, and now the power comes from it, supplying both the load and charging the battery. It's all quite convenient and easy to visualize. You can find the code for this card in the text file. The link is in the description. Now, about the sensors that calculate the power consumed by or drawn from the battery. I had to create them since they are not included in the integration. This is the battery consumption sensor. It has a condition. If the total input power exceeds the total output power, the difference between them is the battery's consumption, and the sensor will display this value. If this condition is not met, then the battery is not consuming anything, and the sensor's value will be 0. The second sensor, which measures the power drawn from the battery, works similarly. The condition is triggered if the output power is greater than the input power, in which case the difference is supplied by the battery. Regarding the power connected to the car/solar input, I recently reviewed a power supply with a battery connection option and UPS mode. There's also a review on the battery, and you can find all the links in the description. In addition, I bought a solar panel cable with an XT60 connector, and the link to it is also in the description. The cable is of high quality and quite thick. I used part of it to connect the battery to the power supply, and the other part with the connector to connect to the EcoFlow. I set a 4 amp limit on the EcoFlow for this input, which gives 50 watts at 12 volts. This way, I increased the capacity of the River 2 by more than 50% in a budget-friendly way. When external power is disconnected, the power from the external unit is used first, and only then does the station's internal battery kick in. The integration is very convenient, and I highly recommend it to all EcoFlow station owners. It can also be used for notifications about power outages, albeit with some delay, or to turn off non-essential consumers if they are powered by the station, either immediately or when a specific battery charge level is reached. There are many options, depending on your needs. That's all for now. I hope this video was useful and interesting for you. I'd appreciate your likes as they help with the promotion of the video on YouTube. In the description, you'll find all the necessary links to the resources, lessons, and devices mentioned, as well as my Telegram channel, Facebook page, and smart home discussion group. Join in. It'll be interesting. Thanks for watching, and see you next time. Peace to all.